Now more complex rules for finding the derivative. So in 1.5 we introduced the basic rules. Constant rule, the power rule, sum and difference rule. And so we're going to add to that with these more difficult higher order rules in the next couple of sections. All right, so in section 1.6 it's the product rule and quotient rule. All right, product means when I have two distinct functions, one function times another. So again, it's not a constant multiplier. We have a function of x times another function of x. So again, there's two functions multiplied together. So f of x times g of x. The rule is, okay, again, the way I have it memorized, and you could have it memorized slightly different. So I have it memorized, it's the first times the derivative of the second plus the second times the derivative of the first. But you could do that in the opposite order. The biggest thing is with derivatives, you can only do one function's derivative at a time. Notice that nowhere in that statement did I do the derivative of f of x times the derivative of g of x. You can't do that. Due to the nature of the limit definition, you can only look at one rate of change at a time. So I can only look at the rate of change of g of x and not f of x. That's the first statement, right? I'm taking the change in g, leaving f alone. And then add to that the opposite. I'm looking at the change in f, and I leave g alone. Right, and as long as you take the derivative of one times the other, and then add the opposite of that, you're okay. So you could do this in the opposite. Some people have this memorized. It just depends if you had calculus before. Flipped it around, derivative of the first times the second plus the derivative of the second times the first. All right, and again, either one of those expressions are equivalent. This is the one I'll be using because that's the way I have it memorized. But both of them are true. As long as you take the derivative of one times the other and add the opposite of that, you're okay. But again, I can only take the derivative of one at a time. All right, so we're going to look at a couple of examples. All right, so this first example, so this would be my first function. That would be, f of x. I was thinking about it in turn, even though it's t. But this would be f, this would be another g function. All right, or first function, second function is the way I do it. So this would be the first, this would be the second. All right, so again, they're two distinct functions. This is a function of t that's a quadratic times, right, times another function of t that's a line. So they're two separate functions being multiplied. And so when I take the derivative of this, you take the derivative of one of those at a time and leave the other one exactly the same. All right, so the way I do it is I write down the first, all right, as is without changing anything, and then I multiply it by the derivative of the second. So I'm going to write it out with the derivative rule. I'm going to take the derivative of the second, all right? So this is sort of a mental step, but I'm writing it out. So it's the first, the derivative of the t minus 1, plus, there's a big plus there, the second, times the derivative of the first. All right, so I haven't actually taken the derivative yet. This is just the rule written out. So the first function as is, the derivative of the second, plus the second. All right, this dt means I'm taking the derivative of that function with respect to time. And so this is, again, is usually a mental step. I'm just writing the rule out for you. We usually, again, do that as a mental step, and you actually write it as you go along. All right, so first, as is, first, times the derivative of the second. Well, the derivative of the second is just the derivative of t. The derivative of t is 1. The negative 1 is a constant. It'll zero out. So there's the derivative of the second. Plus the second function, t minus 1 is the second function, times the derivative of the first. So again, I'm just taking the derivative of the first function. The t squared's derivative is 2t. Plus the derivative of just t is 1. The negative 1 zeroes out. And so there's the derivative. There's the first part. There's the derivative. Now the second part is the simplification. And sometimes students can find the derivative. They struggle with the simplification, the algebra, because it's been a while since you've done algebra. All right, so follow your order of operations. Take care of any exponents and multiplication first, and then add or subtract like terms. And so in the first one, there's not a whole lot to do. I mean, you think about it as distributing your 1, not a lot to do. But this one, I do have to multiply this out. All right, multiply those two binomials. And again, there's different ways students have learned how to do that. There's a box method. I like the FOIL method, inner, outer, and last. First, inner, outer, last. All right, to simplify. All right, so the first term, you really just drop the parentheses because 1 times that expression is the expression. So that just comes down. Plus, then I'm going to multiply this out. So the first, t times 2t is going to give me 2t squared. Outer, t times 1, that's just t. Inner, negative 1 times 2t is negative 2t. And last, negative 1 times 1 gives me my negative 1. All right, so there's that multiplied out. And then you just add like terms. Remember, like terms are things with the same variable parts. So square terms, t terms, and constant terms. All right, so I do have square terms. I've got this t squared and that 2t, so I get 3t squared. Got t plus t, that's going to give me 2t minus 2t. So the t's zero out, right? Those zero out, so I've got no t's. And then negative 2, negative 1, and so negative 3. And there's that expression's derivative. Completely simple. So it starts out complex, but it actually simplifies to a fairly nice looking expression. All right, the second example I'm going to do with you. So again, I've got 2 distinct functions. I've got this first function that's a cube, and the second function, so this is the first, and this is the second. And so when I take the derivative, I only do one of those derivatives at a time. All right, again, what I do is I take the first derivative of the second plus the second derivative of the first. All right, so I write down the first as is without doing anything to it. It's just the first function, x cubed plus 6x plus 5. And so I'm going to skip that mental step. I'm going to skip writing down the rule. It's the first times the derivative of the second. And so I'm going to go ahead and take the derivative of the second and put it here. So I'm looking at the second function, taking its derivative. Well, 3 is just a constant. It zeroes out. The negative 4 is going to come along. The derivative of x is 1, so it's going to be negative 4, 1, which is just negative 4. All right, so there's the first derivative of the second plus the second, so negative 3 minus 4x, times the derivative of the first. So again, there's the second function without doing anything to it, and I'm going to multiply it by the derivative of the first. And I'm going to go look at the first and take its derivative. So x cubed is going to give me the derivative 3x squared. The derivative of 6x is 6, and the 5 will zero out because it's a constant. All right, so there is the derivative. Step 1, get the derivative. Step 2, simplify. And so again, it means multiply out. This time I do have a number, unlike the last example where it was 1. I didn't have to worry about it. This one I do. I have to distribute, multiply through by that negative 4, and then I have to multiply this out. All right, so it's a multiplication step. Distributive, the negative 4, which is multiplying it out, and then FOILing that. All right, so this is going to give me negative 4x cubed minus 24x minus 20. All right, so there's the negative 4 multiplied out. And then this one's going to be multiplied. So first, 3 times 3x squared is going to give me a 9x squared. Outer, 3 times 6 is going to give me a 9. Inner, negative 4x times 3x squared is going to give me a negative 12x cubed. And then negative 4 times 6 is going to give me a negative 24. Negative 4x. Forget saying negative 4x. The x is important. Is going to give me a negative 24x. All right, I'm going to quick double check myself to make sure I did that right. 3 times 3 gives me 9x squared. 3 times 6. There, I did mess that up. That should have been 18. All right, 3 times 6 is 18, not 9. 3 times 6 is 18. Negative 4, 3 is going to give me 12x cubed. And negative 24. All right, so I think I'm good now. And now I collect my terms. My like terms. Remember, my like terms are only my same variable parts. And we usually start with the highest degree. So I've got a cube with this cube. So I've got negative 16x cubed. I've got just the one square term. So 9x squared. Got this x term. And that x term. So negative 48x. And then negative 20, negative 18 is just going to leave me with a constant of negative 2. Alright, so this one's a little more complex. But I started out with a little more complex. I started out with a cube. And I ended up with a cube. So I've got my 16x cubed plus 9x squared minus 48x plus 2 is the derivative of that function using the product rule and then simplifying algebraically. All right, so that's the product rule. You just have to practice it. It's one of those rules that you just have to practice and memorize. So practice and memorize. All right, we'll stop there. We'll pick up the next rule in the next set of notes.